Alright, so we're on journal 26 here, and here it's asking you to verify the trig equation if it is a identity. So we're just checking, is this left-hand side equal to the right-hand side? So we always start with the left-hand side and try to manipulate it using the identities that we know to make it look like the right-hand side. So the first thing that I immediately notice is that I have a cosecant and it's being multiplied to the stuff inside this parentheses. So first, I might want to start with manipulating this cosecant and changing it to a one of its reciprocal identities. So cosecant is also stated to be 1 over sine. Because I notice I'm multiplying here, I want to write this as 1 over sine, so that way when I multiply this through, I can maybe cancel some stuff out. So when I multiply this in, this is going to be 1 over sine times cosine, which is going to be now cosine theta over sine theta. And then the other one would be sine theta over sine theta. Well, sine theta over sine theta are just two things over the same, they're both the same stuff. So whenever you have something over itself, it just ends up being 1. And then cosine over sine actually happens to be cotangent. It's equivalence. And now I've made the left-hand side look like the right-hand side, so I know I'm done. So this is it. I've verified the identity. Okay, so here we have some sum and difference formulas, and there are 6 of them. 2 are for sine, 2 are for cosine, and 2 of them for tangent. Now tangent, I'm not going to be testing you guys on too much, but sine and cosine you will need to know. So we use sum and differences when we want to split up the angles because we don't know what the angles values are using the unit circle, so we're going to use angles that we do know and add them to get to the angle that we want. And I'll show you what I mean in the next example here. So these identities you don't need to memorize, but you do need to know how to use them. Alright, so here I am trying to find what is cosine 75. But if you go to the unit circle, right, typically cosine, you know that it represents the x values where sine represents the y. Well, 75 here is between 60 and 90, and it's not on the unit circle to give us a coordinate to work with. So what we have to do is we have to use the sum and difference angle to help us calculate. So first off, I have to think about how I can get cosine either by adding or subtracting 2 numbers or 2 angles from the unit circle. So using the unit circle here, let's think about it. 45 added with 30 gives me 75. So what I'm saying is I can split this up as cosine, you write this here, cosine 40 degrees, sorry, not 40 degrees, 45 degrees plus 30 degrees, and that would add to give me 75. And so if I want to do this adding or the sum of 2 angles, I have to use that formula that is cosine, I'll write it up here, cosine A plus B, which is equal to cosine A cosine B minus sine A sine B. So using this formula here, I can try to figure out what's the value of cosine 75. So it looks like it's cosine of A, so my A here would be 45 and my B here would be 30. So cosine of 45 degrees times cosine of 30 degrees minus sine of 45 degrees and then sine of 30 degrees. And so if I work this out, cosine of 45 degrees would be right here. And so that's about the square root of 2 over 2. And then cosine of 30 degrees is right here as the square root of 3 over 2. And then this is minus sine of 45, which is the square root of 2 over 2 on the unit circle, because sine here is y. And then sine of 30 is 1/2. And so you can see that once I figure out where they are in the unit circle, I'm just simplifying by multiplying these fractions out. And so the square root of 2 times the square root of 3 is the square root of 6 over 2 times 2 gives me 4. Subtracted by 4, square root of 2 times 1 is the square root of 2. And so the denominators are the same, so you can bring the top together as the square root of 6 minus the square root of 2 over 4. Keep in mind, because these square roots are under square roots, you can't combine them, so this would not be like the square root of 4, okay? It's just going to be square root minus the square root of 2 over 4. All right, and so that's it. I can't really simplify any further. So that's my final answer. Let's try out the next one here. So this one is cosine of 105. As you can see, 105 is not on the unit circle. It's somewhere right here. So what we have to do is pick out two angles that might add or subtract to give you 105. So if I think about it, I think 60 and 45 add to give you cosine of 105. So this would be my A, this would be my B, and using the same formula, since I'm adding here, I just need to plug this in. So I would have cosine of A, which is 60 degrees, times cosine of B, which is 45 degrees, minus sine of A, which is 60 degrees, times sine of B, which is 45 degrees. So now, when I'm looking at this, cosine of 60 is going to be here. So that's going to be 1/2 times cosine of 45, which is the square root of 2 over 2, minus sine of 60, which is square root of 3 over 2, and sine of 45 is the square root of 2 over 2. And so if you multiply this out, it looks like you have the square root of 2 over 4 minus the square root of 6 over 4. And so if you simplify this denominator are both the same, so you can bring the top together as square root 2 minus the square root of 6. And so this is my final answer, because I can't simplify a square root, I can't subtract a square root of 2 with the square root of 6. Okay, and that's it. By the way, that's a minus sign in the middle. My bad. Okay, let's take a look at some more practice problems. So here I have sine of 15. So first I have to think about how to get sine of 15, because it's not on the unit circle. Sine of 15 would have to be between 30 and 0 degrees. So one of the things I've been thinking about is like, well, in the case that the number is relatively small or negative, you might want to use subtraction. So like, I think 40 minus 30 does give me 15. So if I wrote this as sine of 45 minus 30, I know that that would subtract to give me 15. But now the question is, what is sine when you subtract an angle from another angle? Well, sine is sine of A cosine of B minus cosine of A sine of B. So in this case, if I were to follow this, A is 45, B is 30 degrees. And so I would have sine of 45 degrees, cosine of 30 degrees, minus cosine of 45 degrees, and sine of 30 degrees. And so from here, if I were to figure out where they lay on the unit circle, well, it looks like sine of 45 is right here, which is the square root of 2 over 2, times cosine of 30, which is right here, which is the square root of 3 over 2. And then cosine of 45 is the square root of 2 over 2. And then sine of 30 is 1/2. And if you multiply this all out, this is the square root of 6 over 4 minus the square root of 2 over 4, which gives me square root of 6 minus square root of 2 over 4. And that would be my final answer. Okay, so our last one here is we're doing sine of 105. And so this one here, to get 105, just like last time, we had to add 45 with 60 degrees. Let me write 60 first. 60 degrees. It doesn't really matter the order, but. So I have 60 plus 45. And so if I use the formula, actually, the sign adding formula is a little bit different. So if you add two angles, that means there's going to be a plus sign in between instead. It'll be plus cosine A sine of B. And then we have cosine of 45 plus cosine of 60 degrees plus sine of B, which is 45 degrees. And so in this case, cosine of 60 degrees is square root of 3 over 2 times cosine of 45 is going to be square root of 2 over 2 plus cosine of 60 is 1/2. Sine of 45 is square root of 2 over 2. And if you multiply straight across, this is the square root of 6 over 4 plus the square root of 2 over 4, which is added together to be the square root of 6 plus the square root of 2 over 4. And this here would be my final answer. In this last slide here, I'm going to demonstrate how you would do tangent of 15. So we know how to get 15 if you do that subtracting of 45 with 30, you'll get 15. So in that case, if you do tangent of 45 subtracted with 15, you're using, oh sorry, not 15, 30. You'll get 15, so you're using the rule where if you have a tangent and you subtract it from another angle, right, this is going to be tangent A minus tangent B all over 1 plus tangent A times tangent B. And so in this case here, if I were to use this formula, I need to think about, okay, first, I need tangent of 45 degrees, because that's my A, minus tangent of B, which is 30 degrees, all over 1 plus tangent of 45 degrees and tangent of 30 degrees. So to use this formula here, I need to know what tangent of 30 degrees is and tangent of 45, which I can't use directly from the unit circle because the unit circle only tells me cosine and sine. So to figure out tangent, let me work it out on the sine. So tangent of 45 degrees would be these two values. Tangent happens to be sine over cosine, right? So in this case, all I have to do is put sine over cosine. So my sine here would be square root of 2 over 2 at 45 degrees, and my cosine is also the same, square root of 2 over 2. Well, if you have two things that are the same on top of each other and you divide, you actually just get 1. So tangent of 45 is 1. Let's go figure out what tangent of 30 degrees is. So sine here looks like it's 1/2. And cosine here is the square root of 3 over 2. So if you divide fractions, that means you have to multiply by the reciprocal of the denominator. So this would be 1/2. Flip the denominator. 2's would cancel if you multiply straight across. And so this would be 1 square root of 3. But we can't have a 3 root in the bottom, so we multiply it by the itself, and top and bottom. And so if you do that, you get the square root of 3 in the top over 3, because the square root of 3 times the square root of 3 gives you 3 in the bottom. All right, so that means that tangent 30 degrees is the square root of 3 over 3. So if you were working this out, tangent of 45 is 1 minus tangent of 30, which is the square root of 3 over 3, all over 1 plus tangent of 45, which is 1, times the square root square root of 3 over 3 for tangent of 30. And so if you keep working this out, the top here would be 1 minus the square root of 3 over 3. And then if I multiply the bottom out, that's just the square root of 3 over 3, because 1 times that is just still itself. And so what I notice here is that this is a whole number. So just focusing on the top here, they're both, this here is a whole number, so I'm going to change it to 3 over 3 so that I can add with it to the square root fraction. And I'm going to do that for the bottom here. This is just a trick when I notice something is 1 and I need to add it to another fraction. I just make the denominator or the numerator the same, because anything over itself is just 1. So that's how I can switch things very quickly. And so focusing in on the top part here, that's the 3 plus the square root of 3 over 3. And then the bottom would be 3. I think I dropped a negative sign, my bad. This should be a minus sign. Okay, I think I fixed up the top here. So we have plus square root of 3 over 3. And so looking at this here, if I were to divide, basically I'd be multiplying by the reciprocal of this denominator. So this would be 3 minus square root of 3 over 3 times, flip the other one, so 3 over 3 plus the square root of 3. And the nice part is when you flip them, 3's will cancel out diagonally, and so you're really left with 3 minus the square root of 3 over 3 plus the square root of 3. So you're really left with 3 minus the square root of 3 over 3 plus the square root of 3. And you really can't combine anymore or divide anything else out, so this is it. This would be your final answer. Now keep in mind, this has a lot of fraction components. It's not something I would truly test you guys on, but it's still a really good one to know how to do all these steps, because it uses a lot of those algebra skills. All right, that's it for this journal.